Hi, this is Brian Carpenter, and I'm going to talk about the ID on representing IPv6 zone identifiers in uniform resource identifiers. So first, a bit of motivation. Literal addresses in URIs are mainly intended for operational use or diagnostic use, not for normal use. Sometimes we need to take actions relating to IPv6 linked local addresses on a specific interface on the host. A web browser may be the handiest tool for this, for example, just to send out packets that you might want to trace. And it may be the only tool for actually reconfiguring devices whose configuration mechanism is a built-in web server if they're otherwise broken and need to be hand reconfigured. And there's at least one application, CUPS printing, that needs HTTP usage of linked local addresses on a specific interface. So the use case is quite real, even if not very mainstream. Well, we did discuss this 10 years ago, and it became RFC6874. And now the question is, why are we discussing it again? Well, because that RFC was a fail. As you know, we have a standard text representation for a linked local address, as is shown on the slide. That's widely supported and used in IPv6 in general. So RF6874 defined a mapping for the zone ID in URI syntax. No known current browsers support it. The browser community, the WOT working group in other words, decided explicitly not to support it. So what were the problems that produced that failure? Well, it modifies the ABNF of the formal definition of URIs by adding in this new component, a percent sign followed by 25, followed by the interface name. You use %25 as a separator because that's the method in URIs, according to the syntax, of escaping special characters such as a percent sign. Now the problem with that is it prevents cut and paste. You can't cut what you've typed into a ping command and paste it into URL. You have to manually fix it. We previously proposed that because that is the escape character in URIs. But when you actually look into URI parsers and how they work, it turns out you really don't need it. So the proposal with the new draft is simply to drop the %25 and replace it with a simple percent sign. Another problem is that the text of 6874 requires hosts to delete the zone ID from outgoing URIs. That would be in an HTTP host header, for example. That violates the normal behavior of HTTP implementations. At the very least, it's awkward to code, and it actually breaks one of our use cases, namely the CUPS printing protocol. So the proposal now is to simply delete that requirement. Third problem with RFC 6874 is it suggests that URL parsers should support the %25 encoding, but heuristically accept a URI that doesn't contain the percent encoding. So %eth0 would be recognized as the same as %25eth0, except for the exception cases where percent sign could be a legitimate escape. It makes it very tricky to code, it's very confusing to users, so the proposal is to delete this suggestion. And a fourth problem area with RFC 6874 is that it forgot to update the internationalized resource identifier syntax, which is trivial to do, but it means doing an update of a different RFC as well as the original one. So we end up with a final proposal, which is that parsers, whether they're parsing URIs or IRIs, should accept a literal address as shown there, which simply has % and the interface name. The zone ID should, of course, be passed on to the socket API without any need to validate it. And there are no other special requirements for browsers. All the other special stuff we discussed in RFC6874 is dropped. So we need feedback. We contacted a number of senior people in the browser implementation community. The message back from them was very clear. They could implement this, but they will not implement it without strong pressure from users. So our conclusion at the moment is that the best course of action for the IETF is to advance this draft to precisely document the required browser behavior and then wait until that strong pressure from users arrives, which I think it will do as people deploy IPv6 only networks and discover they have no other way to carry out certain operations. Of course, the authors would prefer to receive lots more feedback. Thank you.